Hi, 7th graders. Welcome to video lesson 2.1. This is our textbook solution video for pages 48 and 49 in your textbook. The activity you should have completed is what you see in front of you, numbers 1 and 2, 7 to 10 all, 12 to 18 evens, number 19, 20 through 26 evens, 31 to 33 all, number 35, and 39 to 45 all. Okay, so please be sure you have all of these questions done, or you've completed the modified version if and only if I have asked you to do so, and check your solutions from here. Remember, you are to come here only if you are completed all the textbook work and you're ready to check solutions, or if you needed some help along the way because A, you didn't understand it, or you're not sure why you got something wrong. You are not here just to copy solutions off the video. So the number that we'll be working on will be highlighted across the top. So we are working on number 1. The question is the quotient of two integers always a rational number? And explain. So here's my solution. The solution is no, the denominator can't be 0. 0 is an integer. So is the quotient of two integers always rational? Every other time will be yes. If I'm using the integer 0 as a denominator, the answer is no. So since they used the word always, is the quotient of two integers always a rational number? When I divide two integers, will my answer always be rational? And the answer is no, I can't get a fraction if I have a denominator of 0. Okay, so that's number 1. Okay, here's number 2. Number 2 is asking us, are all terminating and repeating decimals rational numbers, and explain. The answer is yes. These kinds of decimals can be written as fractions. So they are rational numbers. So remember, a rational number is any number that can be rewritten as a fraction. You know, most books will say A over B. If I have a terminating decimal, I can write it as a fraction. If I have a repeating decimal, I could also convert these into fractions. So the answer is yes, because I can write both of these kinds of decimals to fractions. Okay, for this section, we are asked to tell whether the decimal is a terminating decimal or a repeating decimal. So we're going to do 7 through 10 together. So taking a look at number 7, we have 4848 ... That means that this keeps going in a pattern. So since we keep going, this number repeats. It will go on forever. 484848 forever. Okay. For number 8, we have negative 151 thousandths, and there's nothing that comes after it. So essentially, if nothing's coming after it, it's just zeros. That means this number comes to an end. It terminates. So number 8 is a terminating decimal. For number 9, we have 72 and 72 hundredths. We come to an end. There's nothing after this. So since I come to an end, I also terminate. And for number 10, if you notice, there's a bar up here, which is very different from what you saw in number 7. So what number 10 is showing us is negative 5 and 236 thousandths repeating. Now, do you notice the bar notation? That's what this little line is called. You notice the bar notation is over the 3 and the 6. That means the 3 and the 6 keep repeating forever. 3, 6, 3, 6. Do you notice the 2 only shows up once up front? Then the 3 and the 6 keep repeating. 3, 6, 3, 6, and so on. So since this keeps going, our solution here is repeating. Okay, remember you can pause at any point to copy what you need and fix your errors on your papers. Let's move forward to our next series. Our next series, we're looking at numbers 12 to 18 even. So our directions are to write the rational number as a decimal. So I'm going to take a look at number 12. Number 12, we have 1 over 11. These scribbles are just the odd numbers. I just scribble them out to make the page look a little cleaner. So I'm going to show you how to do number 12. If you take a second and look at the bottom of the page, the numerator goes on top, the denominator is the number on the bottom. We could also call the numerator the dividend, and we could also call the denominator the divisor. So if I take a look at 2/3, this is my numerator, the 2, the 3 is my denominator. I could also call the 2 the dividend, or in this case, we'll look at 7/4, and I can call the 4 a divisor. Okay, it's just some vocabulary you should be familiar with. So I will make my division house. The first number, the top number called numerator or dividend, goes on top. The bottom number, denominator or divisor, stays outside. Okay, at this point, I ask myself how many 11s are in 1. There aren't any, so I will add 2 things, a decimal and a 0. Now, how many 11s are in 10? That's 0. So I have to add another 0. And this is a mistake a lot of students make, since they can't put the 11 into the 10. They'll write another 0, but they won't put this one up here. They'll leave that one out. So you have to remember, technically there's a 0 here too. 11 goes into 1, no times. 11 goes into 10, no times. 11 goes into 100, 9 times. 9 times 11 is 99. There's 1 left over. Add a 0 and bring down. 11 goes into 10, 0 times. 0 times 11 is 0. Subtract, bring down. 11 goes into 100 9 times. So if you take a look, there's a pattern here. 11 goes into 1 0 times. 11 goes into 10 0 times. 11 goes into 100 9 times. Okay, so if you take a look here, we get 10 again. So 11 goes into 10 0 times. See that? And then if you look at the next step, 11 goes into 100 9 times. So our pattern kind of pops right up, 0 9 0 9. Our decimal point goes straight up. So our solution, since the 0 and the 9 continue, is 9 hundredths repeating over the 0 and the 9. Okay, at this point, I'm going to erase the work for 12. If you need it, now is a great time to pause. Okay, I'm just going to move this here. Let's take a look at number 14. Please understand, I am doing this division right in front of you, so if I start to slow down, it's because I'm doing the work live as we speak. So 17 is the dividend that goes in the division house. 40 is the divisor. It stays outside. Okay, so now I need to ask myself how many 40s go into 17, and that's 0 times. So I'm going to add a decimal and a 0. So when I look at these numbers, I'm going to ignore the 0 and just look at it as 4 into this number. So how many 4s can go into 17? And hopefully you're saying 4. So 4 times 0 is 0, and 4 times 4 is 16. So it's 160. When I subtract, I get 10, add a 0, and bring down. So now how many 40s in 100? Well, 4 times 2 is 8, so 40 times 2 is 80. And 40 times 3, well, 4 times 3 is 12, add the 0. So it has to be times 2. That gives me 80 here. There's 20 left over. I'm going to add a 0 and bring down. 40 goes into 200 5 times. 5 times 0 is 0. 5 times 4 is 20. And when I subtract, I get 0. Decimal point goes straight up. So my solution for number 14 is 425 thousandths. So number 12, we had a repeating decimal. For number 14, we get a terminating decimal. Okay, this is a great time to erase your boards. Okay, moving on to number 16. So for number 16, I have this whole number here in the front, and I know some of you like to multiply and make this a mixed number, an improper fraction, I'm sorry, and you can do that. But if I start revealing the solution, you're going to see that it's going to begin with negative 2 point something. So if there is an integer in the front, you're just going to carry that over. What you're really converting is the fractional part to a decimal. So what you're going to do is divide the 17 out of 18. So 17, top number goes in, your dividend, your divisor stays out. Okay, I'm going to pause for a minute, and I'll show you what I'm going to do while I pause. What I'm going to do is figure out my 18 times tables. That way, when I'm trying to do my work, I don't have to sit here and think about my 18 times tables. I know this takes a few minutes to do, but it's worth having all of my 18 facts here rather than trying to figure it out while I'm trying to divide. So I'm going to pause, figure out the answers to all of these, and then I'll come back and fill the solutions in. In the meantime, I suggest you give this a shot. So when I go through the explanation of dividing, you get a feel for how I did this. Okay, so I'm back. I was gone for about a minute or two. So why don't you take a minute and check your 18 facts with mine. And it is going to make this division problem so much easier. Okay, so here we go. Let's begin. How many 18s go into 17? 0. So I'm going to add a decimal and a 0 here. So how many 18s in 170? So if I take a look, my highest number is 162. So it has to be 9. So 162, subtract, that gives me 8. And now I'm going to add a 0 and bring down. So how many 18s go into 80? Well, 18 times 5 is too big because the product is 19. So I'm going to use 18 times 4. So 18 times 4, and the product is 72. When I subtract, I get an answer of 8. Add a 0, bring down. Okay. How many 18s go into 80? Again, I'm going to take a look at 4. 4 times 18 is 72. And when I subtract, I'm going to get 8. And if I add another 0, hopefully you guys see the pattern here. This 4 is going to keep repeating. So I'm going to bring this decimal point straight up. So we're going to go back to number 16. So -2 decimal point. So the decimal point here, this one right here that I'm about to color in yellow, that decimal point is the same as this one here that I highlighted in my division problem. -2 and 17 over 18. This is the part. So what I'm doing is replacing the part as a fraction, and I'm going to replace it. I'm going to replace it as a decimal. So if you notice my solution here, I have -2, and I'm bringing the decimal over 94 hundredths with a bar over the 4. The 4 is telling me that the 4 is just going to keep going. If I keep dividing, I'm just going to keep getting 4 times 18 is 72, minus to get 8, and add another 0. So this whole thing's going to keep repeating forever. If you would rather make this a improper fraction, totally fine, and you're going to notice that your first number is going to be a 2, a decimal, and then you're going to get the same thing here. I'm just trying to keep the numbers as small as possible, because the bigger the numbers get, the less fun division is, right? Let's be honest. Okay, I'm going to erase the board and start number 18 now. So for number 18, just like number 16, do you notice there's an integer up in the front, 8? So if I start exposing the solution to you, you're going to see it's 8 point something. This decimal point belongs to the fraction being rewritten into a decimal. So I'm going to take 15 over 22, and I'm going to divide that. Remember, the dividend, or the numerator, goes in. The divisor, or the denominator, go out. Okay, this is a very good tool for you to write down and make sure you know and study, because sometimes dividend and divisor are the words that are going to be used. So it's good to just have it all in front of you. So I'm going to do the same thing with my multiplication facts. I'm going to write my 22 times tables. This one will be a little easier because we're working with 2's, but I still like to have the facts in front of me. And I'm going to do it like the last problem. I'm going to set up my list, then I will pause and write the solutions down as I figure them out, because I have to do the math for these. Okay, so at this point, it would be a good time to pause, and when you come back, I will have the solutions for you. Okay, so there you have it. All the solutions. Just double check yours with mine. And let's begin here. So 22 goes into 15 no times. So I'm going to add a decimal and a 0. 22 goes into 150. It can't be 7 times because that gives me a product of 154. So it must be 6 times. 6 times 22 is 132. So we're going to subtract. That's a 4. This is a 10. 10 minus 2 is 8. 4 minus 3 is 1. At this point, I'm going to add a 0 and bring down 22 into 180. It must be 8 because 9 gives me a product of 198. So 8 times 22 is 176. Let's subtract. 10 minus 6 is 4. I'm going to add a 0. 22 into 40 is 1. 1 times 22 is 22. And let's subtract. 10 minus 2 is 8. 3 minus 2 is 1. I am going to add a 0 and bring down. 22 goes into 180. It has to be 8 times. 8 times 22 is 176. And from 176 to 80 is 4. I will add another 0. 22 into 40 has to be 1 time. Now, hopefully you guys are seeing a pattern, and I'll show you right where it is. So hopefully you are noticing that the 8 and the 1 are repeating. 8 and the 1. So decimal point will go straight up. And remember, this decimal point here where I'm pointing is the same decimal point here in the 8 points. So same decimal point. Now what I'm going to do, instead of writing 15 over 22, I'm going to have these decimal numbers written in place of it. So it's going to be 8 and 681 thousandths with the bar over the 81. Okay, so any questions, please jot them down. Anything that you want to review or have questions on, make sure you're writing those down. So that's the end of number 18. Let's move on to our next series here. It's number 19. So for this example, these are what I like to call standardized test prep questions, because they're asking you to do two things here: to describe the error and to correct the error. So you got the yellow part here in describe and the correct here. So taking a look at this, they're saying that -7 over 11 is -63 hundredths, and the bar is over just a 3. So what we're going to do is set up our division problem as such. If you notice, I already set up the 11 times tables for you. It just makes dividing so much easier. So I'm going to add a decimal and a 0. So how many 11s go into 70? So it has to be 6 times, which gives us 66. When we subtract, we get 4 left over, and we add another 0 to bring down. 11 goes into 43 times. 3 times 11 is 33. 3 left over, add a 0 and bring down. 11 goes into 30. Nope, I made a mistake. This should be 7 and bring down. 11 goes into 70. Can't be 7 times because the product 77 is too big, so it must be 6. So 6 times 11 is 66 with 4 left over. I will add a 0 and bring down. 11 goes into 43 times. So hopefully you can see the pattern up here that the 6 and the 3 are going to continue to repeat. So my solution is going to be negative because there's a negative in the problem. And it's going to be my decimal point and then 63 hundredths with a bar over it. Okay, and then to describe the error, the bar should go over both numbers. So the error is that this student here did not put a bar over the 6 and the 3. And in fact, both digits are repeating, not just one. Okay, remember when you divide, decimal point goes straight up. Okay, we are now going to move on to what numbers are we doing here? Numbers 20 to 26 evens. So for this next segment, we're actually going the other way now. We're going backwards. What we're going to do is take numbers that are decimals and we're going to write them as a fraction or a mixed number. Now fractions are going to be like number 20 and 22 because they don't have a whole number in the front. They have zeros. You guys see that? But if you take a look at 24 and 26, they have an integer in the front, -2, and for 26, a 6. So if you take a look at 24, the answer is going to be -2 and something. It's going to be some fraction. And for number 26, it's going to be 6 and some fraction. All right, so we're going to start with number 20. And the way you read the decimal is the way you write the fraction. And what do I mean by that? So for number 20, we have -9/10. The 9 is in the tenths place. So -9/10 over 10. Now, I ask myself, could I reduce these? And there's no number I can divide both of them by. So I can't divide both of them by some same number to make them any smaller. So my final solution is negative 9/10. Okay, number 22, it is negative 258 thousandths. The 5 is in the hundredths. The 8 is in the thousandths. 258 thousandths. So guess what my denominator is going to be? 1,000. So when students see numbers this big, they kind of take a step back and they're like, I can't do it. What's the common denominator? But you know something? It doesn't matter how many times you divide the number. I know both of these numbers are even numbers because they end in even digits. So what I'm going to start doing is divide by 2. So as long as I can keep chopping these numbers in half, they're going to continue to get smaller. Just don't lose the negative. So 258, I don't know what half of that is, so I'm going to take it and divide by 2. Half of 2 is 1. 2 goes into 5 2 times, and 2 goes into 18 9 times. So I get 129. Half of 1,000 is 500. Students usually write 200, and I'm not sure why. So let's take a look at these two numbers. Could I divide them any further? And I don't think I can. So my final solution is negative 129 over 500. So a problem that looks big and scary suddenly simplified rather quickly. So let's take a look at 24. And what I'm going to do is I'm going to take the decimal part. I'm going to take the 3200ths part, and I'm going to convert that as a fraction. So for my solution, instead of writing negative 2.32 or 3200ths, I'm going to write negative 2 and some fraction in place of 3200ths. So the 3 is in the tenths place. The 2 is in the hundredths place. So 32 hundredths, 32 over 100. Now what I'm going to do is, since they're both ending in even numbers, I'm just going to divide by 2. It's the easiest number to work with. So half of 32, some students give me some pretty wild answers. So 2 goes into 12 6 times. So half of 32 is 16. Half of 100 is 50. So if I take a look at 16 and 50, they're both even numbers again. So I'm going to divide by 2 one more time. So half of 16 is 8. Half of 50 is 25. And I can no longer divide these in half. So my final solution is negative 2 and 8 over 25. Okay, and let's take a look at number 26. So like we mentioned earlier, there's a whole number 6 in the front. So my solution is going to be 6 and some fraction. So if we take a look at the fraction, we have 0.012. So the 0's in the tenths place, the 1's in the hundredths, the 2 is in the thousandths. So we write, you can write 012, or you can just write the 12. And the way I read this is 12 thousandths, tenths, hundredths, thousandths. So 12 thousandths. Now my last job is to reduce 12 thousandths. So since these are both even numbers at the end, divide by 2. So half of 12 is 6. Half of 1,000 is 500. These are both even numbers again. Divide by 2. Half of 6 is 3. Half of 500 is 250. Okay, so I can no longer divide 3 and 250 by a common number. So my final solution for 6 and 12 thousandths is 6 and 3 over 250. Okay, so great work. Thanks for hanging in there. Those were, some tough questions, so great job there. We're going to continue on to the next section now. Okay, so for this section, 31 to 33 all, if you notice, I made T-charts, and what I did was I called the left side the original side, and the right side, I call it the decimal side. So I'm just going to cover up the rest of this page here for a minute, just to make it a little simpler on the eyes. So what we're going to do is order the numbers from least to greatest, smallest to largest. So what I did was I took each of these 5 numbers and I wrote them on the original side. And in my opinion, the easiest way to organize numbers from smallest to largest is putting everything into a decimal, because trying to find a common denominator between 5 numbers is possible, but it's a very, very, very tough task to do. So what I'm going to do is convert everything into a decimal. The good part is some of these numbers are already decimals, like 2 1/10 and negative 75 hundredths. So I know negative 6/10 is negative decimal 6. It's the way I read the decimals, the way I read the fraction. Okay, so save yourself some work. If you don't remember, you'll have to divide it out. I'm going to take a look at negative 9 over 4. Numerator goes in, denominator stays out. 4 goes into 9 2 times. 4 times 2 is 8. 1 left over. Add a decimal and a 0 and bring down. 4 goes into 10 2 times. 4 times 2 is 8. There's 2 left over. Add a 0 and bring down. 4 goes into 20 5 times. 5 times 4 is 20. Subtract. Nothing left over. Decimal point goes straight up. And negative. Just bring the negative sign over. So negative 9 over 4 is worth negative 2 and 25 hundredths. Okay, if you still need this division, pause now because I'm going to erase it. And I'm going to take 5 over 3, and I'm going to do the same thing. Remember, top number goes in, bottom number, denominator, or divisor stays out. Numerator is called numerator or dividend. 3 goes into 5 1 time. 2 left over. Add a decimal and a 0. Let's bring that down. 3 goes into 20 6 times. 6 times 3 is 18. 2 left over. Add a 0. Bring down. 3 goes into 20 6 times. 6 times 3 is 18. 2 left over. Can you guys see that I'm going to keep getting 2? 6 goes into 20, 18. Get 2 left over, bring down a 0. So this is going to keep repeating. Decimal goes straight up. And let's go back to blue here. I'm going to write 1.6 with a bar over it. Now there's something I want to call your attention to. Do you see how I have 1 decimal point here? And I have 1 number after the decimal. Here I have 2. Here I have 2 numbers after the decimal. And here I have 1. So I'm going to make all of these numbers look like they have 2 decimal places. So in this case, a 0 comes after the 1 because it's done. In this case, a 0 comes after this 6 because there's no bar. This is 25. This is 75. This has a bar over it. So what that means is another 6 comes after it. So now all my numbers have 2 decimal places. Do you notice I have 1, 2, 3 negative numbers? So when I order from least to greatest, my negatives must come first. So when I look at this list, I'm going to look at the right column first. Okay? So try to ignore for a minute. Let me cover it for you. We're going to ignore, just for 1 minute, this right side. So of these 3 negatives, who is the farthest one away from the 0? So I'm going to look at these like money. 60 cents, $2.25, or 75 cents. Who's farthest away from 0? And hopefully you're saying this one. So that's my first. This is my smallest. Okay, who comes next? Who is the next farthest away from 0? 60 cents or 75 cents? And hopefully you're saying 75 cents. And third comes 60 cents. Okay, at this point, we finished with all the negatives and we go towards 0. So from 0, who comes next? $2 or $1? So if I'm at 0, who comes next? 1 or 2? Well, hopefully you're saying 1. So 1 and 6 repeating, or 1 and 6/10 repeating. That's 4. And my largest is 2 and 1/10, 5. So what do we do now? So that's a lot of work, and it takes a lot of patience, and it takes a lot of attention. So please be kind to yourself and slow down. So when I order, I want to put these 5 numbers in order, not these 5 decimals. So the good thing is, if I move this little guy over, I know who the original numbers are. So who came first? This guy here. But the original number was -9/4. And then what I like to do is gently cross it out. Don't scribble it where you can't see it anymore, just a little line. In case there's a mistake, you can still read your work. So who's number 2 here? -75/100, which is still the same. Perfect. Okay, and again, you guys are just going to strike a line through here. Who comes third? So on my list, I have -6/10. And perfect, it's still this, actually it's a fraction, -6/10. Okay, put a line through there. Fourth, I have 1 and 6/10 repeating, and originally it was 5/3. All right, we're going to put a little line through here. And last but not least, 2 and 1/10, which is 2 and 1/10. Okay, making these T-charts helps keep all your numbers in order and helps you figure out your final order. So there's your solution for number 31. Please pause, please ask questions, and mark up those notebooks and outlines. Okay, so let's take a look at, I'm going to have to erase this. Let me do this real quick. Okay, we're going to keep this, and we shall delete all of this. There we go. Okay, so we're going to take a look at number 32. Okay, right, everything takes time, right? So for 32, we're going to do the same thing we did for 31. Let's make our T-chart. The lines don't need to be perfect. We just need a little space where we could organize and put our numbers down. Okay, so I'm just copying the original numbers down right now. Okay, Anything that's a decimal, I'm going to write it down. Okay, and these are pretty nice denominators, so they're not going to be too crazy. I'm going to bring this negative over. Okay, numerator goes in, denominator stays out. 2 goes into 7 3 times, 1 left over, add your decimal and 0. 2 goes into 10 5 times, 0 left over, decimal goes straight up. So this is worth negative 3 5/10. Okay, hopefully you guys understand that anywhere you need to pause, please do it. So negative 5/4. I know I'm erasing my work, by the way, but you should not. You should have a spot for all your work. So everything you see me erasing, you should have neatly organized somewhere on your paper next to number 32. Okay, it should all be together. So numerator goes in, denominator stays out. 4 goes into 5 1 time, 1 left over, so we add a decimal and a 0, bring down. 4 goes into 10 2 times, 2 left over, 0 and bring down. 4 goes into 20 5 times, 5 times 4 is 20, nothing left over. So my final answer is negative 1, decimal point goes straight up. Negative 1 25 hundredths. Erasing. And for the last one, we have 4/3. Numerator goes in, denominator stays out. 3 goes into 4 1 time, 1 left over. Add a decimal and a 0. 3 goes into 10 3 times. 3 times 3 is 9. 1 left over. Add a 0 and bring down. 3 goes into 10 3 times. 3 times 3 is 9. 1 left over. Decimal point goes straight up. Hopefully you can see that the 3 is going to keep repeating. So I'm going to write 1.3 or 1 3/10 with a bar over it. Okay, and students ask me all the time, how do you tell who's bigger? And I'm going to show you. So remember in 32 how we added zeros to make everything have the same amount of decimals? Well, I have 2 decimal places here and every other has 1. So this 5 has no bar on it. So the next number is a 0. No bar, so that means the next number is 0. That has 2. Do you notice this number has a bar over it? That means the 3 keeps repeating. So the next digit's a 3. Do you notice there's no bar over this 3? That means the next number is a 0. So this is like saying $1.30. This one's like saying $1.33. So hopefully you can see that this guy is bigger than this guy down here. So when ordering, who do we order first, the negatives or the positives? And I hope you're shouting negatives at me right now. So 1, 2, 3. Those guys come first because they're negatives. We have to figure out their order. What color? Okay, let's do purple. So when I look at these, what's kind of nice is that the integer in the front are all different. Okay, this one looks like $3.50, $2.80, and $1.25. So if I look at just the integers, who's further away from 0, 3, 2, or 1? And hopefully you're saying 3. Then who's further away from 0, 2, or 1? 2. And then this guy is next. And then we have the 2 positive friends. So remember, once we finish with our negatives, we go past 0. So from 0 in the positives, who comes next? $1.33 or $1.30? And hopefully you're saying $1.30. So this guy's fourth. And $1.33 comes next. Okay, remember, in this entire time, oh, that doesn't even work. So that doesn't matter. So now what we're going to do is organize these original numbers from smallest to largest. So just take a look at these numbers we put in the circle. All right, this comes first, but originally it was -7/2. All right, remember, just put a little line through it. Second comes -2 8/10. Okay, this original number. Third, we had -1 25/100, but its original form is -5/4. Okay, fourth, we have 1.3. Put a line through this. And last but not least, we have 1 3/10 repeating, which originally is 4/3. Okay, so congratulations, you just ordered your second set of numbers from smallest to largest. Okay, remember, when we do it in this fashion, all the negatives need to come first. So if you have negatives sprinkled everywhere, we should sit down together and really talk about how a number line works and make you understand the order of numbers, which is okay, but you have to come ask me those questions. So I'm going to erase all of this. If you need any of it, pause it now, otherwise it's gone. Okay, now we're going to take a look at our last example, which is number 33. And we're going to do the same idea. So you'll hear me talk a lot less for this one. We're just going to go right through it. Okay, so copy your original numbers down. Okay, next we're going to convert everything into decimals. I'm just going to put the zeros in now to kind of save that step later. Okay, so this is great. 3 out of my 5 numbers are already decimals. So I'm just going to come over here and convert 11/5 to a decimal. Numerator, dividend goes in, denominator or divisor stays out. 5 goes into 10 2 times, 1 left over, add a decimal and a 0, bring down. 5 goes into 10 2 times, 0 left over. Decimal point, straight up. So we have -2 2/10. Add a 0. You would say that -2 20/100. And finally, we have 15/10. Your dividend goes in, your divisor stays out. 10 goes into 15 1 time, 5 left over, decimal and a 0, bring down. 10 goes into 50 5 times, subtract, 0 left over, decimal, go straight up. So 15/10 is worth 1 5/10, or 1 50/100. Okay? So just like last time, we're going to identify the negatives first, 1, 2, and 3. Those guys must come first because they are smaller than the positives. So if I look at the integer in the front, they're all 2. They're all -2. So that's not going to help me. So we have to look at the cents. So -$2.20, $2.40, or $2.25. Who is farthest away from 0? And hopefully you're saying this guy, 1. Okay, who is farther from 0? 20 cents or 25 cents? And hopefully you are saying 25 cents. And then obviously the next one is this, because that's the last negative. Now we look at the positives from 0. Okay, now we're positive. Who comes next? $1.60 or $1.50? and hopefully you're saying $1.50, and then finally $1.60. Okay, now that we have our order, we can write our numbers from smallest to largest. So our first is -2.4, draw a line. Our second is -2 25/100, draw a line. 3, we have -11/5, draw a line. 4th, we have 15/10, draw a line. And last, we have 1 6/10, draw a line. So our final solution is right here, smallest to largest. Okay, congratulations, you guys did some great work. Oops, sorry about that. And if you have any questions and you're still struggling, please be sure you come and see me. Okay, let's work on the next section now, number 35. So for this one, we have two turtles, a box turtle, which is at -1 5/8 feet, and a spotted turtle at -1 16/25 feet. So we want to know who is deeper. All right, this is a question that some of you still struggle with. I want to know if this is the ground, you know, this is my dirt, who is way deeper in the dirt? Okay, so what we're going to do is convert both of these to decimals. Remember, decimals are way easier to compare than fractions, and it gets rid of the whole deal in trying to find common denominators. So I know this is going to be -1 point something, and so is this. So I just brought the integers over. I'm going to take 5 and divide it by 8, add a decimal and a 0. 8 goes into 56 times. There's 2 left over, add a 0 and bring down. 8 goes into 22 times. That gives me 16 with 4 left over. Add a 0 and bring down. 8 goes into 45 times. That gives me 40 with nothing left over. Decimal goes straight up. So this guy is at -1.625, or -1 and 625 thousandths. I'm going to erase the box turtle work. Okay, now I'm going to do the spotted turtle. I'm going to take 16 and divide it by 25. Okay, when you think 25, think quarters, like 25 cents. So how many 25s in 16? None. How many 25s in 160? Well, 4 makes $1. 6 makes $1.50. That's perfect. 150. Subtract and get 10. Add a 0 and bring down. 25 into 100 is 4. 0 left over. Decimal point goes straight up. So you remember in these examples here, I had you put all of these zeros in to make all the numbers look like the same number of decimal places. We're going to put a 0 here, so both numbers look like they have 3 decimal places. So who is deeper in the sand? -1 and 625, or -1 and 640? And your solution is this guy. This guy is deeper into the ground. Actually, when we talk about deeper or distance, we want the greater absolute value. So if you're kind of stuck, you're like, wait a minute, why isn't it the box turtle? Well, he has a smaller absolute value than this one. So my solution is spotted turtle. Okay, next example. So what we're going to do here is complete each statement with less than, greater than, or equal to. So we're going to do 39 to 45 all. The remaining questions are on the next page just to make our work look a little cleaner and neater. So remember, once again, we are not erasing any of our work. I just do so because I only have a small amount of space. So I have 1 decimal, 1 fraction. So I have 2 options. Try to find a common denominator or just make this guy a decimal. So I know 6/10 is 0.6, so negative 4.6. I'm going to add a 0, compare it to negative 4.65. Who is closer to 0 is the bigger number. This guy is closer to 0, so my answer is greater than. Okay, for number 40, I'm going to take the 3 over 11 and divide. 11 can't go into 3, so I add a decimal and a 0. I get 22. Add a 0 and bring down. That's 77. Add a 0, bring down. 2. So it looks like this is going to repeat. Okay, so this is negative 5. Decimal point will go straight up. And 2, 7 repeating. And this is negative 5.2 repeating. That means the next number here is a 2. So who's closer to 0? 2, 7 or 2, 2? Who is closer to 0? And hopefully you're saying 2, 2, which is this way. Okay, they're both negative, so the number closer to 0 is your bigger number. Okay, for this next one, I'm going to take a minute and write my 14s and 16 times tables because the problem is just going to be really, really long otherwise. So please copy this down. We'll do the 14s as well. Okay, so why don't you take a minute and pause here, and when we come back, I'll have all the solutions ready. Okay, so here are all the solutions. I really encourage you to go through this list on your own and just don't wait for me to put the solutions up because taking a quiz or a test is going to help you tremendously to have your facts in front of you. So it's worth taking that extra 2-3 minutes and writing these facts out rather than stressing over the division. So I'm going to do this negative 2 and 13/16. So I know my answer is going to be negative 2 point something. And the same here. Okay, so I'm going to take 13 over 16. I'm setting this up wrong. Your numerator or your dividend goes in, and your 16, your denominator stays out. So I'm going to add a decimal and a 0. How many 16s in 130? And the answer is 8. And I get 128. 2 left over. Add a 0 and bring down. 16 goes into 21 time. That leaves me with 4. Add a 0 and bring down. 16 goes into 42 times. That's 32 with 8 left over. Add a 0. 16 goes into 85 times, and that'll get me to 0. So this is negative 2.8125, or negative 2 and 8,125 10,000ths. So I'm just going to move this answer here. And I'm going to erase the work for negative 2 and 13/16. And we're going to now do the work for negative 2 and 11 over 14. Numerator goes in, denominator stays out. 14 goes into 110 7 times. So 7 times 14 is 98. Okay, 11 becomes 10. 10 minus 8 is 2. That's 1. Add a 0 and bring down. 14 into 120 is 8. 8 times 14 is 112. Subtract, that gives me 8. Add a 0 and bring down. 14 into 80 is 5 times. That gives me 70 with 10 left over. Add a 0 and bring down. 14 into 100 is 7. 7 times 14 is 98 with 2 left over. Add a 0 and bring down. 14 into 20 is 1. So I'm honestly not sure if, when, or where this problem will end. Like I said earlier, I'm doing these problems live in front of you, but I have 4 digits here and more than 4 digits here, and I think I have enough to compare my number. So decimal point will go straight up, negative 2.7857. 1, 2, 3, 4, 1, 2, 3, 4. Remember, the goal for these problems isn't to divide out all the decimal places, but it's to have enough decimal places to compare. Okay, I want to know, because they're both negatives, who is closer to 0. So when I take a look at these two, I have negative 2.8 or negative 2.7, and clearly who's closer to 0? And hopefully you're saying 2.7. So this one's bigger. Everything else, I really don't need it because the directions aren't convert to a decimal. It's just, hey, tell me who is bigger. The next one, students really dislike, and the directions are to find one repeating and one terminating decimal between these two fractions. So students have a really tough time with this because when they look at these fractions, students just see fractions. And when I see fractions and I see decimals. So when I look at these two, what students do is they'll find common denominator and make them 6. But the problem there is the directions say I want a terminating decimal and a repeating decimal. So even if you do find common denominator, you're not really answering this question because this question wants one terminating and one repeating. So what we're going to do is convert these to decimals. So if you need to do the math, go right ahead. This one is like 50 cents, so a half is 50 cents, half a dollar. And a third, if you don't believe me, I promise you, it's negative 3/10 repeating. And for the fun of it right now, we're just going to call it 33 cents. So the directions are between negative 50 cents and all the way to negative 33 cents. Give me one decimal and then give me one repeating decimal. So there's literally an infinite amount of solutions. So we can say negative 49 hundredths or negative 48 hundredths or negative 47 hundredths or negative 46 hundredths. Do you guys see this pattern now? I mean, once you see it, most students are like, oh, why didn't I see it? Negative 44. And then the repeating part, once students see the terminating part, they're like, well, how do I come up with a repeating decimal? And this is the simple part, but it's too easy that students don't like it. Take any one of these terminating decimals. Let's go to one we haven't written yet. Say 35 hundredths. Negative. Just put a bar over it. Take any one of these numbers and put a bar over it. So students get kind of crafty and they'll write negative 42 hundredths, semicolon, negative 42 hundredths, put a bar over it. And you know what? That's perfectly fine because both of these numbers are between a half and a third negative. Okay, so you can literally take any of these terminating decimals and put a bar over it to make it repeating. It's that simple. Okay, let's move forward. So in softball, a batting average is the number of hits divided by the number of times at bat. So what that looks like as a fraction is hits over at bat. Okay, so if we take a look at Eva, Eva is hits divided by at bat. And if we take a look at Michelle, she is 38 over 80. So what we're going to do, we could find common denominator. And I mean, these are kind of huge numbers already. So to be honest with you, I'm not interested in doing that. But if you do, great work for you. But I'm not going to do it. I'm just going to divide these numbers out. So I'm going to take 42. I'm going to divide it by 90. Add a decimal and a 0. 9 goes into 42. Let's see. 5 times. That's 45, so it's got to be 4. 36. That's 6. Add a 0 and bring down. 9 goes into 60. Can't be 7. 6. So that's 54. All right, add a 0 and bring down. So we get 600 again. So it looks like this 6 is going to keep repeating. So we get 46 hundredths, 6 repeating. Okay, and then we're going to work on Michelle here. We're going to take 38 and divide it by 80, decimal and a 0. 8 goes into 38 4 times. Yeah, 8 times 5 is 40. 8 times 4 is 32. Add a 0 and bring down. 8 goes into 60. 6, 7, 8. So it's got to be 7. That's 56. 40 left over. And 8 goes into 40 5 times. Done. Oops, sorry about that. So this is equal to 0.475 or 475 thousandths. Remember, if I want this to look like a 3-digit number like this one, since the 6 repeats, the number that comes next is not a 0, but it's another 6. The question here is, does Eva or Michelle have a higher batting average? And my answer is Michelle has a higher batting average. Okay, because her decimal is way larger. So let's go to 44. So let's just clean this board up a little bit. Okay, number 44. You missed 3 out of 10 questions on a science quiz. Okay, and 4 out of 15 questions on a math quiz. Who has a higher percent of correct answers? So if you got 3 wrong out of 10, that means you got 7 right out of 10, because 10 minus 3 is 7. So if I times both of these by 10, that gives me 70 out of 100. So your grade is a 70% for science. For math, if you missed 4 questions out of 15, well, 15 minus 4 is 11 out of 15. And I really can't multiply this by anything to get to 100, so I'm stuck going to a decimal. 11 divided by 15. So how many 15s into 110? So 30, 60, 90, 6 to get 90. Add a 0. So bring this decimal here. So 15 into 200, so 15 times 6 is 90. Oh wait, I made a mistake. This is too big. So it's got to be 7. So let's see. 15 times 7. So 7 is 105. Okay, 15 into 50. So 15 times 2 is 30, so 3 is 45. So I get another 5. So it looks like the 3 is going to keep. So I get 0.73. I'm just estimating that. So this is roughly 73%. So who scored higher? And your answer is math. Okay, 73 is higher than 70%. And the last one, believe it or not, it's an absolute value question. Is the half pipe deeper at the skate? Is the half pipe deeper than the skating pool? So it's simply yes or no. It's saying, is this number here deeper than this number here? So it's saying, is this absolute bigger than this one? So the answer is no. Explain. 10 is deeper than 9 and 5/6 feet. You can put feet in here. Okay, 10 is deeper, not 9 and 5/6. So congratulations, you just made it to the end of 2.1 lesson. So great work for sticking it through.